Alright, in this video we're going to focus on theorem number 5. What does theorem number 5 says? It simply states that opposite angles of a cyclic quad are supplementary. And when we talk about supplementary, we're just saying that they add up to what? To 180 degrees. If I've got angle A plus angle B, they will add up to 180 degrees. That's what supplementary means. So what does that mean? If we look at this diagram, we've got angle B and angle D. So they're simply saying that this angle that we have here, angle B, and the angle that we have there, which is angle D, when you say angle B plus angle D, they add up to 180 degrees. And your reason would be that opposite angles of a cyclic quad now observe, we also have got angle A here and angle what? And angle C there. It also means that angle A plus angle C, they're equal to 180 degrees. And it's still the same reason, opposite angles of a cyclic quad, right? Now, then they ask, prove that angle B plus angle D is equals to 180 degrees, or angle A plus angle C, they're equal to 180. They are supplementary in other words. So here's the question. I'm going to use angle B and angle D to prove. Prove that angle B plus angle D are equal to 180 degrees. So what I want to use, the reason which I'm going to use, they are not available here. But the first thing which I'm going to indicate is the fact that we have got a center somewhere there. And this center, I'm going to name it point O. Now, the reason and the logic which I want to use, it's not available here. So the onus is on me to what? To inform the examiner that I'm going to use such and such and such. That you did not provide me in the diagram. So what do I want to do? I want to join point A and point O, and I also want to join point O and point C. Now remember, this is the center, and the distance from the center to the circumference is what we call radius. So here we've got OA, which is radius, OC, which is also radius. So we've got radii. That's what I've created. So now I come and I say join OA and OC. Now that I have announced to the examiner and I've joined also on the diagram, what am I going to do? Now I'm going to indicate that I've got this angle here, angle O. Now I'm going to call it angle O1. And also I'm going to indicate there that outside this reflex angle here, this is angle O2. What do I want to use? I want to use theorem number 2, which states that the angle that is at the center is twice that the angle which is at the circumference. So in other words, I'm not going to tell the examiner that angle O1, which is here, is 2 times bigger than angle D. So now I'm saying angle O1, right? Angle O1 is equal to 2D, meaning to say that 2 multiplied by angle D, right? Now, not only do I talk about that, now, if you check angle O2, or if you remember, angle O2, this reflex angle that we have here, remember, is at the center, and it's twice the angle what? Angle B. So we now say angle O2 is equals to 2 times angle B. But now, let's use some numbers here so that this can make sense. All right. So, I'm going to say that around here, angle O1, I'm going to say that I've got 120 degrees. So, if here I've got 120 degrees at angle O1, and I write that angle O1 is equals to 120 degrees. Remember, we said that the angle at the circumference is 2 times smaller, which means that half of 120 is 60, which means that there I've got 60 degrees. And now that I've done that, Remember, angle O1 and angle O2 are what we refer to as angles around a point. And angles around a point, they add up to what? 360, which is a revolution. So now, if I've got 120 here, now I say 360 degrees minus 120 degrees, which will give me 240 degrees, which means that the reflex angle that I have here, angle O2, is 240 degrees. Remember now, this reflex angle is 2 times bigger than angle B, which means that here half of 240 is equals to 120 degrees. So in other words, I'm now going to say that angle O2 is equals to 240. And I now say, remember, O1 is 2 times bigger than angle D. So when I now write the equation, now I write that angle D is equal to, remember, angle O1 is what? Half angle D. So now I write half and angle O1. What is half of angle O1? It's 60 degrees. So there is my angle D. Then I come and I now write angle B here. I say angle B is equals to half angle what? Angle O2 here, and angle O2 is 240. So half of angle of 240 is equals to 120. Now, I know the measure of angle B, I know the measure of angle D. Now I say angle B, which is equals to 120. So I say 120 degrees plus 60 degrees is equals to 180. And the reason which I used, we say that angle at the center is 2 times the angle at the circumference. That's what we do. I'm sorry for the picture. I do not know what's happening with the camera. Right? But yeah, basically that's your theorem number 5. And that's what happens under theorem number 5. Right? So I will be now saying that 2 times the angle at the center or at the circumference. Angle at the center is 2 times bigger than the angle at the circumference. That is the reason that I used. And I've proved that angle B plus angle D is equals to 180 degrees. And just like that, that's your theorem number 5. And you can see 120 here plus 60, it is equals to 180 degrees. All right. Please join me on the next video where I talk about the what? Where I talk about the converse of this angle, because it's also important. And also, one last thing. At the end of all these theorems, I'm going to do a summary where I give you tips of how to categorize the 9 theorems in such a way that when you approach the exam, it will be easier, because there is wording which is used in an examination. So at times I know that it is difficult for people to what? To remember all 9 theorems. But the tips which I will give in the summary, they will make it much easier for someone to remember or to cope with the examination. All right. Please don't forget to share, like, comment, and subscribe. Thank you.